What's up, people, and welcome to my tutorial series in Introduction to Blockchains. And in the previous tutorials, we have been looking at different nodes, trying to create transactions with bank accounts and eventually syncing up to agreeing on a balance that has been made. And in the previous video, I showed you how one of the nodes was overwritten, all the transactions overwritten by the one with the longer chain. And in this simulation, I just exited and agreed that, okay, my transactions was crap. Let's just throw them away. But what you would do in this case, you would of course rehash them, say that, okay, your chain is longer than mine, and I'll just throw mine away, but I'll keep my transactions that I'm throwing away and remine them with the same chain that I received from you, right? So it'll still be there, but the balance of the accounts will be correct, right? Because it'll be in the right order. And what that means in theory is that the one with the most processing power is going to have the advantage. And I suggest you ponder about this for a while, see what implications it gives. And also I can recommend this really good article. I'll put the link in the description, called Analysis of Hash Rate Double Spending. And the article shows that if you have more than 50% of the processing power in the nodes, you can always be a bully and with 100% success rate determine what the blockchain will look like with all the transactions. And I'm not going to go too deep into it. It's better if you read the article. They're probably going to explain it better than I do. And the problem in our implementation occurs here in the merge chain, and it occurs here when you check the length. If it's greater, we just swap them around. Here you need to do some other stuff, right? For example, you need to remine the ones that you remove when you do this. The transactions are lost here, so you need to figure out how to do that. And also another interesting part is the mining part, because here what we do is we create all these nodes, right? If you check the configurations here, for example, here we create a Genesis block, all is fine, right? And here we create another block in the blockchain, but here we run the behavior mine, which is gonna mine the Bitcoin, find out the nonce and everything, and we do it ourselves. But in a Bitcoin environment, for example, you could outsource this part of the behavior to someone else, and you can lazily have the link to put together without hashing, and then wait for the whole links to be hashed. Now we need to wait for them to be mined in order to create the next one, which is obviously not optimal. So in a real environment, what we do is we still create this chain, but all the mining of the chains and updating the hashes and the chain and so on, that's going to be handled by someone else, basically a miner pool or whatever, what have you. So that's one of the issues. So in order to exploit this system, basically what you would do, if let's say that this is a Bitcoin implementation and you have an e-commerce system where you can pay with real money with this service, right? So you can pay with this currency that I have created here. The way you would exploit it is right here in the posting part, right? So you would create a chain that looks like this. You would create a chain that has a couple of blocks in it, and it has a couple of transactions, right? So in here, the last transaction that you do is that you buy something. And then you post that chain, updating the balance of the accounts, as I showed you in the previous tutorial. And then you would wait, but you will still continue on working on a separate branch like this. And then you would wait. When you will create, this chain will be very long. Then you would wait, you know, all the other guys, they're gonna continue, right? Like building up the chain also with different transactions that they made in the system. As soon as you receive your good, in this case, the stuff that you're buying, I don't know, some electronics or whatever, as soon as you have received that, then you post a longer link. And in this longer link, you exclude the transactional of the money to the other guy, which basically means that you have performed a double spending, which the article that I have linked to illustrates this. So you would have both the good and the money, because the transactions on the longer chain is going to be accepted, and in those transactions you don't transfer any money to the guy that you're buying from. And that is how you could exploit it if you have, with 100% certainty, if you have more than 50% of the processing power in the cluster. And I think that is it for this tutorial series. I'm going to post the link to the GitHub repository also, of course, in all the videos. And it might be a bit buggy and you might run into troubles and, of course, running it and stuff, but please take your time trying to fix it yourself. This is no working system whatsoever. It's just a simulation demonstration for the sake of the tutorials. But hopefully you'll have some fun with it and play around with it and try to create bigger simulations, for example. I would love to see that. And also, if you do play around with it, please let me know in the comment section. Maybe you can post a link or something, and so I can have a look at it if you like. But with that being said, I hope you enjoyed this tutorial series and you got some inspiration and kind of like have some better grasp of how you could use blockchains and what they're used for and how they work and so on. And I hope you guys liked it, and yeah, see y'all.